Well, let's talk about community monitoring data. I think everyone should be able to share if you have anything to share, Shelley. Um,
I
I'm
do. I do. So let me work out what I'm doing. So I'll share that. And then if I go, oh, fuck. I don't know if I just do that, is it going to do it onto this two screens? Yeah,
no,
it'll
that's
work.
okay.
You guys are seeing that?
One screen. That's good.
Cool. Sweet. So yeah, I'm just here to give, hopefully it's a 15-minute can I get rid of that? There, I've got that over to there. Ugh, right. 10 to 15-minute presentation on sort of guideline values that can be used in freshwater monitoring. This is just an initial corridor around the subject. This is a really big subject. And so at the moment, I'm just focusing on giving you guys a bit more information about the different guideline values that are currently used in the Focus Catch-up Map series, and where those have come from, but also recognizing that there is a guidance document coming out in the near future that pertains to what are some good guideline values that can be used for community-based monitoring. So I don't want to sort of circumvent that with what we're sort of talking about, which is why I've kept this to what's currently in the Focus Catch-up Map series as a starter. Um, right. Thanks. Why is that not? There we go. So, to start with, we're just going to talk a little bit about the National Objectives Framework. So, this comes out of the National Policy Statement for Freshwater 2020. In the Focus Catch and Map series, this is the stuff that sits at the top. They're the round circles on the maps. This is the stuff that you see on LAWA when you go to LAWA, and I've got the A, B, C, D bands. So the NOF came around as part of the NPSFM and it places requirements onto the regional councils. And that includes identifying freshwater management units within their region and within those FMUs, identifying the values that are important for those individual FMUs. And that work is done whilst engaging with communities in tangata whenua, and that's kind of where the Y Connection project kind of slots into that process. For each value, they then need to set environmental outcomes and identify attributes for each of those values. And each of those attributes then need to have baseline states, targets, and limits set. And that's kind of like where the NOF interpretation or attribute bands come into play. And on top of that, they need to prepare action plans to achieve that stated environmental outcome. Wrapped around that, they need to do monitoring of the freshwater environment. And that shouldn't say EOS, it should say State of the Environment Monitoring, SOE. So they need to monitor their SOE sites, which is basically what's up on the LAWA site, and take action if degradation is detected. Um, they use the monitoring to measure progress towards those target attribute states, and the monitoring needs to be designed to assess trends in the identified attribute states, and it needs to meet the minimum requirements set out for each of those attributes in the NPSFM. So that's where all the little gremlins come into, how you use, suitability for the NOF attribute bands for the type of data that you've collected. Do you have enough of it collected, etc.? And that is why when you go onto the LAWA site, sometimes the monitoring site hasn't actually had an attribute band assigned to it, and that's because they've deemed the monitoring data that has been provided for that site hasn't met the minimum requirements or met the requirements for determining that attribute band. So this is just a little table that we did up on the NOF and on the NOF values and where they sit. So they kind of get split up into two different categories. Those attributes that require usage limits applied to them, and attributes that require action plans around them. So, yeah, ammonia and nitrate toxicity and your suspended fine sediment, those are usage limits. So basically, the regional council identifies what the limits are that they want to be meeting. And so that'll usually be taking those NOF bands of A, B, C, D, where do we, within this FMU, what NOF band are we wanting to achieve? And as a minimum, they shouldn't be below the national bottom line. And sometimes there's either one or two of those bands that will sit below the national bottom line. But ultimately, the regional councils, in consultation with their community, decide on which one they're sort of trying to achieve. With the action plans, they identify those targets, but instead of having a limit that they're sort of working towards, they're sort of setting up the action plans that are going to help with them to sort of achieve those. And so that's where you, for example, your dissolved oxygen and your deposited fine sediment kind of sit within that, as well as your E. coli for your contact recreation. So there's a bit of complexity around the usage of those NOF attribute bands, and how they get used by regional councils, and how they get used within a region. So in summary, the NOF bands are used by regional councils. There's a number of criteria that need to be met. Usually it's 5 years of data. So when you go onto the Lawa site, it's usually showing a median value for 5 years. Water quality, that often needs to be done monthly, but there's a whole bunch of other sort of criteria in there as well. For example, under the fish IBI score, you've got to use conventional sampling, and it's got to be done in a certain time of year and other things like that. There's also a few of them that have data conversions that are needed. So for the ammonia toxicity NOF attribute band, you actually need to, it's the toxicity, because ammonia is toxic, more toxic at higher pH. It has been, the toxicity values for that has been based on a pH of 8 and a temperature of 20. So if you're monitoring and you want to know about ammonia, and you're wanting to look at that, or the council's wanting to look at that NOF attribute band for ammonia toxicity, then you need to take that data and you need to convert it to standardize it against a pH of 8 and a temperature of 20. So there's a little bit of stuff that needs to be done on the data before you can then compare it. They are designed as targets that the regional council set. So that kind of means that those are the levels that they're not wanting to exceed. So in that way, they're kind of more like an upper limit. They're not necessarily, unlike some of the other guideline values that are out there, this is kind of like, as a region or for this freshwater management unit, we don't want this nitrate to go over this, and we need to sort of work towards what we can do to prevent that from happening in the first place. So it's not really one that you're looking to use to kind of go, hey, we're not there, everything's fine, we don't need to do anything, bugger, we're over it, what do we do now? It's actually trying to prevent sort of exceeding that limit in the first place. Also, some of the attribute bands are actually based at the toxicity level, not at the trophic level, or not effectively not looking at those chronic effects. So they're definitely not worthwhile you sort of using those as the early warning system if you're sort of exceeding those poorer bands for those toxicity, ammonia toxicity and nitrate toxicity. Things have gone are pretty dire if you've kind of exceeded those lower bands on that. So it's not good as an early warning system. So if you're doing work with sort of community groups and stuff, you kind of want to, in my mind, sort of keep away from those, because that's your worst case scenario that you don't want to get to. That's the train has gone off the end of the cliff by that point. And all of these limits are obviously based, there's one value across the country, so they don't differ regionally. Just to look a little bit more on those toxicity things. So we've got under the NOF, there's the nitrate N toxicity and there's the ammonia toxicity. But then when you look at the dissolved reactive phosphorus, that's actually a trophic state one. So that's looking at chronic effects. So in a way, you're not comparing apples with apples. The one is telling you these amounts of nitrate in so high that they're becoming toxic to biota, and you're comparing that against a DRP value, which is actually looking at those chronic effects. So it's keeping that in mind. And also, while it's really important, if you're looking to present information that's based off the NOF bands, whether you're taking the regional council's LAWA data and you're sort of wanting to communicate that further to your community group, always use that full term, because there's a big difference between nitrate N and nitrate N toxicity, just like there's a big difference between nitrate and nitrate N. So whilst it's always nice to be able to simplify things down and have less words, those types of things, we need to make sure that we're always presenting the full term. Even if we're looking at guideline values, so all of these have a single value, right? There's a single guideline value for DRP. It's either in the NOF, you've got sort of different bands for that, or if you're using the Australia, New Zealand guidelines, you've got a default guideline value that you're either above or below. But there's actually, when you dive in deeper into these sort of, particularly with the water quality ones, there is actually a stage that you sort of move through. So these things can affect animals, periphyton, fish, invertebrates in completely different ways. And so their level of tolerance to them actually differs depending on what part of the ecosystem that you're looking at. So this is some work that was done by the Science and Technical Advisory Group. So the STAG group actually was the group that did the majority of the work around establishing those NOF bands for the Essential Freshwater Program. And as part of that work, they looked into a bunch of other potential attribute bands or guideline values that could be developed for other things that didn't end up making it into the MPSFM NOF criteria, but it's a really useful one to kind of show and delve down into how the chronic effect of something can actually be quite different across different trophic groups. So this is looking at dissolved inorganic nitrogen. So again, this didn't make it into the final NOF, but they worked out their median value for their A, B, C, and D bands under that same approach of NOF. But then they actually also had this table here that split this out based off each of the different trophic states. So for periphyton, invertebrates, fish, ecosystem processes, and then they had the average. So the average is what ended up going into, the equivalent of the NOF band. But when you have a look across here, you can see that the level of dissolved inorganic nitrate that starts to have an effect on periphyton is quite a bit higher than it is for invertebrates. And then on the flip side, fish, can tolerate a much greater level of dissolved inorganic nitrogen before it starts to affect them. And the same deal with dissolved reactive phosphorus. You can see that invertebrates are actually more sensitive to DRP than periphyton, than fish. And so when you're looking at these average values, they actually, you lose a lot of that information about where what's going to get hit by these changes earlier than other things. And so I think that's just really important to bear in mind regardless of whatever guideline value is recommended or that you end up using, is that understanding that actually there's effects that start to occur in different parts of that food chain, despite the single value that's given. Moving now on to the ANZAC guidelines, Australia, New Zealand guidelines, sorry, they used to be called the ANZAC, now they're the ANZG values. So these are developed for Australia and New Zealand. They were done up in 2018 to replace the old ANZAC values. They're actually online, so it's an online thing. You can't get like a hard copy PDF or anything of this. It's effectively a website that is a little bit of a headache to sort of navigate around, but the URL's there, and it's certainly worthwhile going and having a look as to what's on there. So they provide default guideline values. So these are nationally based. So like the NOF stuff, they are nationally based, but they do differ based on topography and climate for some of the criteria. And when I say they differ based on topography and climate, how that gets used is by using the river environment classification, topography or source of flow data, and the climate data. So, those first four maps in your focus catchment map series have that information in there. And so depending on depending on what your climate and topography is for a site, you're going to have a different default guideline value for a lot of the water quality parameters. The difference between these guideline values and the NOF stuff is that these guideline values are based on a trigger system. So if you exceed that guideline value, that is a trigger to investigate further. So this is more like an early warning system. So the values that are presented under the Australia and New Zealand guidelines are going to be lower than the NOF bands. Because again, we're talking about this is more of an early warning system that things are starting to sort of move off what you would expect them to be versus the NOF bands, which is kind of like, we don't actually want to reach the D band. Actually, we don't even want to reach the B band. We want to stay in the A band. So very different sort of use and approach for those two values. So in that regard, the DGVs are probably better for working with community groups because you're wanting to sort of help for them to identify that things are starting to shift away from what you'd expect the baseline to be. And so that's where you can start to help with, well, what are the things that we can do to sort of turn that around or prevent that from sort of getting worse. So the graph on the exit on the right-hand side will look familiar to some of you. This is the taken out of the little DGV's sort of brochure handout that we did that goes along with the Focus Catch and Map series. And that just shows you how the trigger value, or the default guideline value actually changes based on what the topography and the climate class is. So if you've got mountain topography and the cool sort of climates, then your guideline values for some of these things these are actually quite, when you're looking at turbidity, these are quite a lot higher than they are for the equivalent climate within a hill category. And so that comes down to, and any of you that took part in the Focus Catch and Map series presentation that we had a couple of weeks ago, this is where that information is coming into play, where the mountain, streams that are fed by mountain topography have a naturally higher suspended sediment load in those systems. It's just part of the natural system. And so therefore, their default guideline value is going to be higher for streams that are dominated by that type of topography. And obviously you don't have mountain areas that have warm, well, in New Zealand, you don't have mountain areas that are warm and dry. So that's why there's no value sort of available for those. And so you see a similar thing as you go through nitrate, N and DRP, that your values kind of, when you go from your hill and the cool dry down to your low elevation, your nitrate N values are starting to get, quite a bit higher. And your, when you look at your DRP, those are slowly sort of elevating as well. So again, this is pretty important to feed that stuff back to your community groups. This is not a one shoe fits all type of approach. You do need to know what those guideline values are for your climate and topography. And obviously that all connects back to the rec layer, and the rec layer is not always accurate at the site level. We know that. So you may have a site where there isn't a rec line there, or you may have a site where the rec line, when you zoom in, the rec line is kind of, several meters away. You can still use that rec line if that rec line represents the stream that's there. It's just not visually sort of accurate at that point. You can still pick up the information that's sort of presented on it. In terms of how you can take your data and present it, and in my mind, and this is based off 25 years of kind of looking at environmental data and what are the things that can have the greatest sort of impact on them. I think looking back, and again, this is using those top four REC classifications, so the river environment classifications of climate, topography, geology, and the fourth one is land cover class, is quite a good way to sort of group those, because land cover, as we know, um, the different land uses within a catchment, do have a big effect on our aquatic ecosystems. And because the REC classifications of those is based off looking at a point within a lineal length of a stream network, and it's looking from that point, looking upstream and determining what's the dominant land use that sits above that area. So you may have a myriad of different land uses within that, but it's going to be picking the one that's most dominant. And when we look at those four catchments that have different REC land cover class categories, you can see sort of differences coming through here. For example, on this particular catchment, the tussock land cover classes just under half that of the pastoral. So, pastoral land cover class has a higher DRP, median sort of value for DRP coming through those systems. And of course, that's based on, a reasonable amount of data. So again, that's kind of a handy way to do it if you're wanting to look at trying to work out what the patterns are within your system, trying to move away from site-based, because a single site and looking at the data from a single site doesn't always tell you about what's going on in the catchment as a whole. So, I'd recommend that you do your site-by-site comparisons, but then also start to group your sites into different classifications. And one of those is your land cover class. This is just an example from some work that Courtney here has been doing with one of her catchment groups. So this is their data that they've been collecting. So she's kept them separated out based on site, but she's sort of visually grouping them by their topography classification. They're all in the same climate, so that's a given. And then, you can already see that the default guideline value for nitrate N for the hill classification is lower than what it is for the low elevation. So it's a nice way to sort of visualize and kind of see that, okay, this value is actually not that much higher than some of these other values, but actually it's below the default guideline value, whereas these ones are sort of miles above it. Oh, that's weird. Okay. It doesn't look like it's supposed to. It's got all the information there. That's what we want. Just some other sort of parting comments on other stuff that you can do. I haven't wanted to delve into this too deeply because there is this further guidance that's kind of coming out that Juliet's working on and that I'll be working on for the invertebrates. I don't know where that is currently in the pipeline. I haven't had the information come through to me for me to sort of work on the invertebrates, but it is coming. And so I just want to be careful that we're not putting out, I want to see that information first before giving you some firm sort of thou shalt use that versus not using this. So just be patient. That's on its way. But in the meantime, some other things that you can keep in mind, and a lot of you guys know this already, your water quality data, you obviously need lots of sampling from that to build up a really good picture. So certainly monthly, probably at a minimum, if not weekly or more often. But then things like DO and temperature, you've kind of really got to have continuous loggers in to start to build up a picture of that because they have such a strong diurnal variation. On the flip side, if you're wanting to look at what's happening as a result of runoff from a catchment, especially if you're in a more urbanized catchment, but it would also apply to rural catchments, then you might want to focus on rain event sampling. So obviously with your suspended sediment and things like that, knowing the difference between whether a sample's been a rain event sample or during a prolonged period of stable flow makes a big difference to interpretation of that information. And Also with water quality, you obviously always want to be presenting based on the median values, not the average. And the graph on the little graph inset there is just a box and whisker plot. And this is based off, I think, 4,000 data points or something. I mean, this is a huge amount of data that's presented in these two graphs, but you can see the solid line is the median value and the dashed line is the average value. And there's quite a difference between those two, even with a data set that has a lot of data. So typically the average isn't used for water quality because water quality can be so variable. And you can see with all these little dots here are the outliers in the data set, and you can see the whiskers, the error bars on here are quite broad. So, water quality data is inherently variable. And so if you use the average value, those bigger and smaller values are going to just have a disproportionate effect on your average. And you can see here, we've got lots of values that are outside the spread of the data, right? And so that is what's responsible for pulling that average value down. And so your median values kind of just takes that into account. So median for water quality. But on the flip side, for invertebrate data, you're better to, you can use average values for that. And partly that's because your invertebrates, you only need to do yearly sampling, really, unless you want to look at seasonal changes. Yearly sampling is totally fine. And that's because invertebrates, they have they've got a life history. So their life cycle may be 1 or 2 years that they're spending in the larval stage. In their ecosystem. And so as a result, their communities, the monitoring of those communities, you're seeing the effects of, months, 12 months or so, their life cycle of effects on those communities. And so that's why you don't need to do it as often. And also you don't get those, because water quality you have to do more often and it chops and changes a lot. Invertebrates, that the using the averages is more suitable than the median. I'm not going to cover invertebrate indices here. That's another presentation in of itself. There's a lot of hooks involved in that and a bit of a headache. So I think once we've got these guideline values sorted out, we can have another sort of workshop on that. But ultimately, with all of these things, what would be, I think, really useful to do is use more than one guideline value. It's the same as don't just look at one thing. So don't just only look at nitrate N. You want to look at a range of water quality parameters. Same deal. Look at more than one guideline value because they are telling you different things. And so they're going to add to the nuances of the story and of what's going on. And you'll also have regional guideline values. So you'll have your regional plans that will have values in there for a number of the parameters. And so talking to your council or looking up online sort of what those are as well is going to be really useful. And so, yeah, certainly whenever we present data, we will typically put a bunch of different, compare it against a bunch of different sort of guideline values as well. So I'll stop there. Oh my God, that was 27 minutes. It was supposed to be 15. So I'm going to stop talking.